The 506 Carlton streetcar line is one of the oldest routes in Toronto. The line provides service to residential neighborhoods, offices, as well as important locations such as the University of Toronto, Queen's Park, and Chinatown. Fast forward to today.
As you can see, the 506 Carlton route has now been temporarily replaced by buses. This is due to a shortage of streetcars as well as planned construction. While this line previously operated using 32 streetcars, there can be now as many as 45 buses running along the 15-kilometer route during peak periods. On a typical weekday, the line carries upwards of 40,000 passengers, which makes it the fourth busiest route in Toronto.
During the course of this investigation, we have noticed that there are several concerns along the route. One of the very first things we've noticed is that there is uneven demand along the stations within the route. No passenger typically uses more than half of the line. In other words, there are very few people who travel from Main Street Station in the east to Hyde Park Station in the west, or vice versa. Now, this is likely due to the fact that both the terminals along the route and along with are situated within the Bloor-Danforth subway line, which represents a faster alternative to travel between those two terminals. In the morning peak hour, the majority of passengers traveling eastbound alight somewhere within the downtown core, while the majority of passengers traveling westbound also alight within the downtown core. Now, we're here at Queen's Park Station, which is a popular destination for passengers to alight on either direction to catch the Yonge University Spadina line. The operational schedule of the 506 Carlton is set with very short headways to meet the high demand within the middle section of the route, or in other words, Toronto's downtown core. Now, one issue resulting from this was that there are way too many buses servicing the very low demand sections in the outer portion of the route. Now, this leaves the outer sections very underutilized, if not completely empty, while still maintaining those short headways at those stations. Now, while short turning would be problematic for streetcars because there are few locations to do so, buses represent a much more flexible form or mode to execute short turns, which may help in improving the utilization.
After analyzing the issues of the line with more detail, we believe the increased operating speed of buses offers a major advantage over streetcars, especially along low-demand sections. For this reason, our proposed recommendations are based on a permanent adoption of buses along the route. Under current operational conditions, the transit route operates based on a headway of 2.5 minutes and has a fleet size of 53 buses. We are proposing the following 4 recommendations to improve the transit route.
So we noticed buses stopping along College Street poses an issue for cyclists. While this isn't a problem during the winter, it may become a more pressing issue as we approach spring and summer. If buses become more permanent, boarding islands similar to the ones found on Wellesley Street should be considered to accommodate both cyclists as well as bus passengers. Boarding islands will help improve accessibility to the buses. It will also help reduce bus kneeling time required, potentially improving dwell time. Boarding islands will also improve safety by keeping bystanders and cyclists separated from each other.
Our second recommendation involves using articulated buses in replacement of the traditional bus. Traditional TTC buses offers a capacity of 53 persons, while articulated buses offer a capacity of 77, which represents a 45% increase. Based on our observations of the current operating conditions along the line, the adoption of articulated buses would reduce the fleet size by 20 while maintaining the same capacity along the route. The implementation of this strategy would result in an increased headway of 1.5 minutes, which is still acceptable even during peak periods.
Since too many buses service very low demand in the outer section of the route, our third recommendation involves implementing express bus service to reduce the travel time of transit users. The implementation of an express bus service would allow a fleet reduction of 8 buses while providing headways of 5.5 minutes.
Our fourth recommendation involves the adoption of transit signal priority for the buses on the route. The installation of transit signal priority at 4 major intersections along the transit route would reduce cycle time by 7.8 minutes, therefore reducing the required number of transit units operating on the route by 3.
Articulated buses offer the advantage of reduced fleet size, but represent significant capital costs to deploy along the entire route. Express buses, on the other hand, offer travel time savings for its passengers, but don't necessarily offer the same degree of transit unit savings as articulated buses. Therefore, our recommendation would involve using articulated buses for the express route and regular buses for the local operation. Our recommendation also involves transit signal priority at major intersections, which would further save transit units and reduce travel times for passengers. This recommendation would provide a major cost savings, reducing fleet size by 9 while providing an average headway of 5.5 minutes.